So for the second day of 1.5 notes, we're going to take what we did before and kind of build on it. So take a second and do this warm up for me so that you can see if you really have a good grasp of what we did yesterday. So go ahead and pause the video. All right, so now if we want to go over these, interval notation, remember that's where you have either a bracket or a parenthesis. So on this one, farthest to the left is negative infinity, and to the right would be -3. And it's going to be a parenthesis because it is not included. It's an open circle. Set notation, remember we would do our variable such that, and then our variable, this ends up being less than -3. On the next one, our interval notation, farthest to the left would be 3/4, which again is a parenthesis because it's not included. And then all the way to the right is infinity. Remember, with infinity and negative infinity, it's always a parenthesis. Set notation, we have our squiggles, x such that, and this time x is greater than 3/4. And then our last one, all the way to the left is 0.3, which is a bracket because it's a closed circle, and then to infinity. Set notation would be squiggle, x such that x is greater than 0.3. So building off of what we just did there, we are going to do the same process, but now we have to solve first, okay? Probably the main thing from solving is if you multiply or divide by a negative, you flip your inequality. Okay, this is like the huge part of today, okay? Multiply or divide by a negative, you end up flipping your inequality. The only other time that you flip your inequality, which I've talked about before, is if you're left with like 1 is less than x, you always want your variable first. So you flip everything around to make it x is greater than 1. But again, it's kind of like you just focus on the fact that it is at the pointy towards 1, so that means the pointy part should be towards 1 if you move it. So if we look at number 4, on this one, first thing we would do is subtract 15. And when we do that, we get -3x is greater than -30. And then we divide by a -3. Which, like I said, when you divide by a negative, your inequality flips. So instead of being greater than, it'll be less than. -30 divided by -3 is a +10. So we put 10 on our number line. Open circle because it is not equal to. And less than is to the left. So interval notation, all the way to the left is negative infinity. And then to the right, our farthest one is 10, and it's a parenthesis because it is an open circle. Set notation is x such that x is less than 10. The letter B, this time, you can distribute the -3 in, or you can divide it over. Either way, you're going to end up with the same end result. Most of you will probably think to distribute it, which is fine. So we have -6x minus 6 is less than 10. So we would add 6 to the other side. So we have -6x is less than 16. And then we divide by a -6. So because we divided by a -6 on both sides, we flip the inequality. Now, this is not a whole number or an integer, so we are going to just reduce. So if you divide both of them by 2, you get 10 over -3. Okay, I'm fine if you put a decimal, I just prefer fractions. Notice in the beginning when we multiplied by a negative, we did not flip the inequality. That's because we only multiplied one side. It's only when you're doing both. So in our graph, we would put -10 thirds. Remember, it doesn't matter where that negative's at. Open circle because it's not equal to, and greater than is to the right. So our farthest left is negative 10/3, which is a fraction, or sorry, not a fraction, is a parenthesis because it's not included. It's an open circle. And then to the right is positive infinity. Set notation, x such that x is greater than 10/3. So as we keep going, it just gets a little bit more difficult of problems. So on letter C, probably the first thing that I would do is distribute the -4. Once again, I know I'm multiplying by -4, but it's only one side, so we're just going to keep it the same. We have -12x plus 4 plus 6x is greater than or equal to 16. Now I'm going to combine like terms on the left. That would end up giving me -6x. And solving for x, we would subtract 4. So -6x is greater than or equal to 12. And now when we divide by -6 on both sides, we would flip our inequality. So x is less than or equal to -2. This time, we would have a closed circle at -2 because it is or equals to. And it's less than, which is to the left. So we would be from -infinity to -2 with a bracket because it is equal to. And set notation, x such that x is less than or equal to -2. Letter D, I would first start by multiplying by -4. Remember, when you multiply by -4 on the right, it cancels it. So you are not multiplying the numerator as well. Okay? All it does is cancel the -4 in the denominator. So we're left with -24 is less than 7x minus 3. Notice how I switched my inequality because I just multiplied both sides by a negative. We add 3 to both sides. So -21 is less than 7x. And divide by 7. Now take a second and think, would we flip our inequality for this step? So the answer is no, because this is a -21, but a positive 7. Okay, it doesn't matter that the 21 is negative. We really are only paying attention to the 7. So because the 7 is positive, it just stays as -3 is less than x. The problem is now our x is on the right instead of the left. So we do need to flip everything, which means we flip the inequality as well. So we have -3, open circle because it's not equal to, and then we would shade to the right because it is greater than. So farthest left is -3, farthest right is infinity, both parentheses. And then set notation, x such that x is greater than -3. Moving on to letter E. Okay, this is a situation where if you recognize this, you can do it this way. You don't have to. So just like before, you can solve it different ways. But for me, I noticed that everything, I can divide everything by a -3. So instead of distributing the -3 and making more work for myself, I'm just going to divide it over right away. So we're left with 2x minus 5 is greater than, and then we're going to divide each piece. So -6 divided by -3 is 2x, and 9 divided by -3 is -3. At this point, if we get x's to the same side, we would notice that our x's actually cancel on both sides. So we're left with -5 is greater than -3. Now, if this were an equal sign, -5 equals -3, we would know that would be no solution. But this time it might be infinite, okay? So it's no solution if it's not true, but it's infinite if it is, right? And that's the same thing as if we had an equal sign, right? So let's think about this. Is -5 greater than, oh, what did I forget to do? Flip my inequality when I divided by a -3. Okay, so think back to the very first step right here. I should have flipped my inequality. Okay, so we're actually looking at -5. It's less than -3. Is that true? Well, yes, -5 is less than. So our answer is all reals or infinite. Okay, now we still need to do something over here with that. That means that every number would work, so we would shade the whole number line. Interval notation, all the way to the left is -infinity. All the way to the right is positive infinity. And set notation, I would take a lot of answers here. I'm okay if you just put infinite or all reals. If you want to make it more formal, like x such that x equals all reals, that's fine with me. Any of those would work. Or you could put your r with a line through it. So on this next one, I'm actually going to change it really quick. This is supposed to be a less than sign. It's a little bit of a typo. So pretend it's a less than sign from the start. Okay. So on this one, if you distribute the -3, okay, because you can divide both sides by -3 if you'd like, but if you distribute the -3, you'd get -6x plus 15 is less than -6x plus 9. If you get your x's to the same side, they end up canceling, and you're left with 15 is less than 9. Right? We know that that is not a true statement, so that means that we have no solution here, right? So that means on our number line, we would have nothing to shade. And then in interval notation and set notation, we have no solution as our answer. Now again, set notation, you can do x such that x equals no solution if you want to, but I'm fine with just doing this, or the most correct would be probably to put no solution in the braces. They're called braces, squiggles, whatever you want to call them, okay? All right, and then our last problem. Okay, on this one, it says Derek wants to order some roses online. For what number of roses is it less expensive to order from florist A? So florist A is $4.75 per rose plus $40. Okay, and we want to know when it's less expensive than doing $5.15 per rose plus 25. Okay, so we can go either way to solve for x. What I'm going to do is move the x's to the left. So subtract 515x. And if you take 475 and subtract 515, you get negative 0.4x. And so then we're going to subtract 40. So negative 0.4x is less than 25 minus 40, which is negative 15. Our last step is to divide by negative 0.4. Flip our inequality because we divided by a negative. And if we do that, we get 37.5. So this means after 37.5 roses, it becomes the better order. So that means that at 38 roses, it is the better order, right? Because you're never going to get half a rose.